practical situations I write on the board to identify certain things. Okay. For example, if we talk about, let us say, yes, Shadhavli, please stand up. The number of hours he runs treadmill. Okay, the number of hours he runs on treadmill and the number of calories he loses. Correct? Then let us say Divyaji.
Yes.
Sir, height of person and weight of person. Height of person and size of shoes. So both can go with Divyaji, right? Then let us say Rekha. Renuka, stand up. Let us say expense of women. We know it's always much more. So expense of women and amount of savings which they are able to do presently. Okay. And let us say that Shiva, stand up. He is a businessman, so price of commodity and demand of commodity. I'll be asking you a few questions based on this. Those who are standing particularly. So, okay. And let us say, Vadari, stand up. Let us say the same thing, number of hours of exercise and loss of or weight of a person, simply weight of a person. Now, two things I am going to ask you over here. So, Atavil, tell me the relationship between the first three. Tell me the relationship between the first three. Related to mostly? No, you are going in the wrong direction. Relationship between the two means direct relation or inverse relation. Now specifically tell me, do they have a direct relation or an inverse relation? Like in last year you should have studied price, demand, price, supply, etc. So tell me between the first three there is a direct relation or inverse relation? Inverse relation. Okay, you sit down. Divyaji?
So,
Direct relation. You sit down. Direct relation. Sit down. You tell me between the last three, what kind of relationship is there? Direct relation. Okay, sit down. Madari? Inverse relation. Okay, sit down. Now, check your answers. Between these three, we have direct relation. Atavle, more number of hours you spend on treadmill. Will you lose more calories or less calories? More calories. So there is direct relation. More the number of hours you spend on treadmill, more the calories you lose. Is everyone clear with it? Renuka. More the expense of women, more will be the savings or less will be the savings?
Less.
More the expense of a woman, less will be the amount of savings. More the price of a commodity, lesser will be the demand. And more hours you exercise, lesser will be your weight. More hours on treadmill, more calories you lose. More the height of a person, more the weight. Less the height of a person, less the weight. More the height of a person, more will be your, larger will be the size of shoes. Less the height of a person, lower will be the size of your shoes. So here you find there is direct relation, and here you will find there is inverse relation. Is everyone of you clear with it? Now raise your hand. If I ask you, out of these two, which one is cause and which one is effect? Can you identify that? Raise your hand. Which one is a cause and which one is an effect? Raise your hand. In each of the situation, you have to answer it to me. Parik?
Number of hours we run on treadmill is a cause and number of calories we use is effect.
Number of hours he runs on a treadmill is a cause, and the number of calories you lose is your effect. More hours you spend on treadmill, that is a cause. Because of that, you will lose more calories. So that is your effect. That's in the second one.
Height of a person cause and weight of a person.
Yes, height of a person is a cause and weight is the effect. As your height will increase, your weight will keep on increasing. Is everyone clear with it? So all these left side items are basically what? They are the cause. And all these right side items are what? They are the effect. Now if I write one more example, let us say number of hours studied by dash marks scored by Swara. Now, what is the kind of relationship first of all? Dash, direct or inverse? Indirect means the more number of hours, dash will study, less marks, Swara will score. That is indirect relationship. Okay. And Swara, which one is the cause and which one is the effect? Yes? Is the cause. Okay. Cause. Is that so? Marks scored by Swara is the cause. Means if Swara scores more marks, then only Dash will study more. Basically, there is no cause and effect relation between the two. Both are independent to each other. Don't always try to establish a dependent relation. Both are independent of each other. Number of hours studied by Dash will affect the marks of Dash and only Dash, until and unless someone is copying from it. Okay, and the number of hours studied by Swara will only affect the marks scored by Swara. Here there is no cause and effect relationship. Such a type of relationship where cause and effect exists is called correlation. Such a type of relationship where cause and effect exists, what do you call that as? Correlation. Okay. We are going to start with stats chapter 2, which is basically linear correlation. The name of the chapter is linear correlation. Why the word linear is used, I'll explain you as we progress in the chapter. But what is the meaning of correlation is clear to every one of you. So let us define what is correlation. All of you repeat. Cause and effect relationship.
Cause and effect relationship
Between two variables. Such that changes in the value of one variable results in changes in the value of other variable. Did you understand this? Basically, changes in the value of one variable means changes in number of hours will result in change in number of hours. So the first one is a cause and second one is an effect. Okay, so once again, how to define it? Cause and effect relationship between two variables such that changes in the value of one variable results in changes in the value of another variable. It's called correlation. Is everyone of you clear with it? And there are two types of changes possible. One is both go in the same direction. One is increasing, the other is also increasing. The other is both go in the opposite direction. One is increasing, the other is decreasing. Or one is decreasing, the other is increasing. The first one, where both of them going same direction. One increases, other increases, or one decreases, other decreases, is called positive correlation. And the second one, where both of them going opposite direction. One increases the other and one decreases the other, is called negative correlation. Is everyone of you clear with this? Any confusions in that? So write down the definition of correlation. Give the heading in your notebooks, chapter 2, linear correlation. The reason for starting chapter 2 and not chapter 1 is chapter 3 is related to chapter 2. Chapter 2 is the cause, chapter 3 is the effect. That kind of relationship is there between the two. If you understand chapter 2, chapter 3 you'll be able to understand. Chapter 4 is related with chapter 3. So these three chapters we'll try to finish in the vacation itself. First part has total 4 chapters. Chapter 2, 3 and 4 will finish in the vacation itself. Okay, that is the reason of starting it. And one I take after your school reopens. Did you get the heading chapter 2 linear correlation?
Are you sure that spelling is correlation?
CORRELATION. I'm 100% sure. Did you all write it down?
No, wait, sir.
So write down the definition. The cause and effect relationship. The cause and effect relationship between two variables such that slowly after that what will you write? Such that
Variable 1 will revert into variable 2.
correct. And such that changes in the value of one variable results in changes in the value of other variable is called correlation. So, all are clear with the meaning of correlation? Now, what are its two types as we have discussed? So, give the heading types of correlation and there are two types of correlation we can mention here. One is positive correlation, the other is negative correlation. Okay, and what happens in positive correlation is both the variables change in, yes, same direction. Both the variables change in same direction. And what happens in negative is both the variables change in opposite direction. Any confusion in this?
No, sir.
Very good. Now do one thing. Below positive correlation, write on the first three examples. First three, that is, you write it this way: number of hours a person runs on treadmill and number of calories he loses. Second example, height of person and weight of person. Third example, height of person and size of shoes. Okay, this three you write under positive correlation, and the remaining three examples you write under negative correlation. Is everyone clear with it? See, normally we know many examples, but when it comes in exams, if they ask you to write three examples, you'll not be able to write it. Therefore, I have written three examples each. Can you give me any one more example of positive correlation? Yes. Price and supply. Any another example? Price increases, supply will increase. Price decrease, supply will decrease. So positive correlation. Any other example of positive?
Rain of agriculture.
Two people are speaking. What did you say?
Rain and agricultural production.
Rain increases, agricultural production will increase. Rain increases much more than agricultural production will decrease. But yes, rain increases, agricultural production will increase. Rain decreases, agricultural production will decrease. What were you saying? Okay. And negative correlation, any one more example you can give me? See, positive is income and expense also. You earn more, you'll spend more. You earn less, you'll spend less. So income and expense. Negative correlation, any one more example?
Number of hours of reading. Next number of study. No, this is not it.
Number of hours and
Roaming is study.
roaming. Now that's obviously. If you roam for more hours, you study for less hours. It's opposite relationship. Okay? Or you can say the temperature and the consumption of tea. As the temperature increases, the consumption of tea decreases. As the temperature decreases, the consumption of tea increases. And if you say temperature and consumption of ice creams, then direct relation positive. As the temperature increases, consumption of ice cream will increase. As the temperature decreases, consumption of ice cream will decrease. Okay, so remember more number of examples. If asked in exams 3 or 4, you must be able to write. Now, how to find the correlation between two variables? Okay, there are 3 different methods which we are going to study. There are 3 different methods which we are going to study over here. Before the methods of studying correlation, we understand one more term which is coefficient of correlation. Where did we study the word coefficient in last year? Raise your hand. Khushali? Measures of dispersion, range, and then coefficient of range. Then quartile deviation, coefficient of quartile deviation. Then mean deviation, coefficient of mean deviation. Then standard deviation and coefficient of variation. Skewness and coefficient of skewness. What was range, quartile deviation, standard deviation, mean deviation, and skewness? Absolute measure. And what were the other coefficients? Same thing over here. Correlation is an absolute measure, and coefficient of correlation is a relative measure. Is everyone familiar with it? But here you can say we assign a number to correlation. How strong is the relationship or how weak is the relationship? That number is called correlation coefficient. Basically, correlation is a qualitative measure, a qualitative aspect. The relationship between the two variables does exist. But when you give a quantity to that relation, quality, you give a quantity means higher number will show good amount of correlation, lower number will show less amount of correlation. That numerical figure is called what? Coefficient. In short, you can say like elasticity of demand. But when you assign a number to that, then it becomes numerical measure. Same way here also. When you assign a number to correlation, it will become coefficient of correlation. So write down. Heading down coefficient of correlation. The numerical measure. The numerical measure of correlation is called coefficient of correlation. Is everyone clear with this? Further write down, it shows, first of it shows the strength of relationship. It shows the strength of relationship between two variables. Is everyone clear with it? It is denoted as R. It is denoted as R. And minus 1 less than equal to R less than equal to 1 means the value of this correlation coefficient will always lie between minus 1 and plus 1. Minus 1 and plus 1 are the highest degrees of correlation. Minus just means negative. Plus just means positive. Like the first 3 examples we have seen, your answers will come positive. The next 3 examples what we have seen, price and demand and other examples, there your answer will come negative. But if your answer comes near to 1, let us say minus 0.95, then we will say strong negative correlation. Near to 1 we will say strong. Near to 0 we will say weak. Minus 0.95 is close to 1. Strong negative correlation. Minus 0.05 is close to 0. Weak negative correlation. 0.8 is close to 1. Strong positive correlation. 0.1 is close to 0. Weak positive correlation. So the extreme ends possible are minus 1 and plus 2. Minus 1 perfect negative correlation. Plus 1 perfect positive correlation. Is everyone familiar with it? So this is how the numerical measure will be assigned. Now we take up with the methods of correlation. So 3 methods we are going to study in the chapter. Put your pens down, don't throw them down, put them down. And put it down one time only, not again and again. Now, methods of correlation. There are 3 methods we are going to study in the chapter. First method we'll discuss today itself. Tomorrow. 3 methods. First is silence, scatter diagram method. First is scatter diagram method. Second is silence.
We have to write.
Afterwards. First is scatter diagram method. Second is Karl Pearsons product moment method. Karl Pearsons product moment method. And third one is Spearman's. Spearman, S-P-E-A-R, not Superman, neither Spider-Man. Spearman's rank correlation method. Maintain silence. So 3 methods are there. Scatter diagram method, Karl Pearsons product moment method, and Spearman's rank correlation method. Okay. First one is a graphical method that we will now take up tomorrow. Drawing the graph will be able to analyze. It is not much expected in exam, so in 5 to 10 minutes only we'll finish it tomorrow. It's a small part. And Karl Pearsons product moments methods will have 6 formulas in all. So those 6 formulas I'll give you tomorrow, which compulsorily you'll have to write 20 times so that you remember them. And Spearman's rank correlation method will have only 1 formula. Okay, so these 3 things we have to study in this.
We have to bring graph.
You don't have to bring the graph, we'll be doing it in the notebook itself. Okay? Yes, be attentive. What is scatter diagram method? Understand this. Until 11th standard, you have been studying univariate data. Univariate means single variable x was involved in all the chapters. Chapter 2 onwards we started studying it, chapter 3, 4, 5, all we studied single variable x. In 12th standard, all the chapters you have bivariate data. 2 variables are involved. Like we had number of hours of running on treadmill and number of calories lost. Now 2 variables we will denote as x and y. First one, which is x, we always call it as independent variable. The cause is always independent. Like if I ask you, number of hours run on treadmill and number of calories lost, which one depends on what? Calories lost depend on number of hours you run on treadmill. So calories lost is which variable? Dependent. And the cause of calories lost is number of hours you run on treadmill. That is the independent variable. Independent variable will always denote as x, and dependent variable will always denote as y. Any confusions? And on the graph paper you make 2 x's, x-axis, y-axis. Horizontal is x, vertical is y. And you mark the points of intersection of values of x and y. And the diagram which we obtain is called scatter diagram. You also call it as dot diagram. Not dot diagram. Dot diagram. Because the diagram is visible in the form of dots. It is also called dot diagram. So understand which 5 kinds of diagram are possible and how to interpret the correlation from the same. Okay, you write it later, just understand it first. If you get there is x-axis horizontal, there is y-axis vertical. If you get the points of intersection in upward rising straight line, upward rising and straight line, we call it as perfect positive correlation. Plus 1 is its value. You can see as x is increasing, y is also increasing. That's why it's upward rising. And because it's on a straight line, it's perfect positive. That's why we are studying the chapter linear correlation, because we study the relationship along the straight line. So it's called linear correlation. Same way, if you find after making the diagram that the dots are falling down in a straight line, that will show perfect negative correlation. Here you can observe that as x is increasing, y is decreasing. Inverse relationship. Here both are going in the same direction, here both are going in the opposite direction. Any doubts with this? If after making a diagram, you find that they are upward rising but not in a straight line. They are upward rising but not in a straight line. Then we say there is partial positive correlation. And 2 types of partial are possible. High degree, low degree. High degree when they are near the straight line. If you find diagram of this kind, high degree positive. If you find diagram of this kind, away from straight line, then low degree positive. As they come near to the straight line, high degree, exactly straight line, perfect. As they go away from the straight line, low degree. But high degree and low degree both come under the category of partial. Same way, if you find that the dots are falling down but not in a straight line, near to the straight line, then it is partial negative correlation. And if you find that they are not at all in a line, then we say there is no linear correlation. It is very necessary to write the word linear. If you simply write no correlation, no marks. 0 marks. Because what we are studying in this chapter is only linear. When we say no linear correlation, it means other type of relationship is possible. Curvilinear, circular, any other kind of relationship is possible. Nonsense, spurious. Like I give the example. Number of hours studied by Fenning, marks scored by Fenning. Linear correlationship is not there, but between Fenning and Fenna, other type of relationship may exist. So there is no linear correlation, but other type of correlation may exist. Whenever in this chapter your answer comes r equals to 0, you will not write no correlation. What will you write? No linear correlation. Is everyone familiar with it? Questions are very simple and scoring. We'll start that tomorrow. Study diagram. X and Y values will be given. Not even graph paper is needed. In the notebook itself, we'll make the diagram. And looking at the diagram, we'll give our judgment. Is it perfect positive, perfect negative, partial positive, partial negative, or no linear correlation? First, write down the definition of scatter diagram, then note down this. Any confusions with this? Raise your hand who did not understand the first method. So, write down. If the values of x and y, after that write this way, x1, y1, x2, y2, x3, y3, dot dot dot, xn, y means whatever number of values of x and y are given. So the pairs of values x1, y1, x2, y2 up till xn, y are plotted on the graph paper. Then the diagram so obtained is called scatter diagram. Any confusion with this? Next paragraph. Looking at the diagram, comma, the type of correlation can be known. So it is shown as below. Note down all these 5. Okay. So everyone is clear with this scatter diagram methods concept? So tomorrow without fail everyone must have textbooks, pencils. It will be required for making these diagrams. Scale. Okay. Calculators also will be needed. They should be along with you. We'll start with the practical question exercise 2.1. Page 66, exercise 2.1, question 1. A ball pen making company wants to know the relation between price in rupees and supply in 1000 units of its most selling gel pen. The following information is collected for it. Draw a scatter diagram and interpret. Price rupees market as X. There are two variables. Independent variable we always mark it as X. Monthly supply 1000 units market as Y. Any confusions with this? Supply depends on price. So supply is dependent variable, that is Y. Price is independent variable, that is X. Any confusions? Means in our graph, price will be shown on horizontal X-axis. Supply will be shown on vertical Y-axis. Now in price, what is the minimum? 11. Maximum? 17. So we can take scale of 1 centimeter 1 unit. We can directly start with 11. And we'll write from 11, 12, 13, 14, 15, 16 up till 17. In supply, what is the minimum? 12. Maximum? 53. So we take 1 centimeter as 5 units. 5, 10. We'll directly start from 5. And up till 55. Any confusion with that? So first give the heading. Scatter diagram showing question 1. Scatter diagram showing correlation between price and supply. Okay. Now y-axis, x-axis. On x we will show price in bracket rupees. On y-axis we will show monthly supply in bracket 10,000 or 1,000 units. Any confusions with this? Now see, understand this concept, then you can continue writing it. Put your pens down and you will just understand one point. See, minimum is 11, maximum is 17. So there are two ways of writing it. Suppose you take the scale of 2, then you can simply write 2, 4, 6, 8, 10, 12, 14, 16 and maximum is 17. So we'll write up there. What is the scale we take here? 1 centimeter as 2 rupees. And so we start also directly with 2. Another alternative is you take the scale of 1. What is the minimum value? You directly start with 11. So 11, 12, 13, 14, 15, 16 and 17. Got it everyone? But earlier what scale did we take? 2. And we started also with 2. Now what scale we are taking? 1. But do we start with 1? So here you will break the line and you will do this kind of a sign. So like if you are having a string with you and you squeeze it, how does it appear? So 1 to 10 all are included. He squeezed that. If we would have started with 1 itself, then this breaking the line is not. Okay, like earlier we started with 2, scale is also 2, then breaking the line was not needed. Got it everyone? Any confusion with this concept? See, in Y we will not break the line. What is the scale we are intending to take on Y? 5. And we start also with 5. So there you need not break the line. Directly you can start with 5 up till 5. Any confusions with that? Right. And here on the top right hand corner you mention the scale which we have taken. On X it says 1 centimeter equals to rupees 1. Okay, it's rupees and we have taken 1 unit only. On Y axis 1 centimeter equals to, we have taken 5 and you can see here it's in 1000 units. So 5000 units. Understood that everyone? Here is 1 centimeter 1 rupees, here is 5 but the units are in thousands. So here 1 centimeter actually indicates 5000 units. This is 5000, 10,000, 15,000 and so on. Raise your hand who did not understand the scales. Who are still writing it? Everyone has plotted the points. Shall I start with the diagram? Raise your hand who is still writing it. So I'll start with it, okay? Now it's very simple. First value, can you see 14 and 32? 14 of price is directly available. Can you all see that? But 32 of supply is not directly available. So between 30 to 35, you can say this is 31, 32, 33, 34, 35. Roughly, you just mark it approximately. And out of that, so this would be 32. 14 and 32, where do they intersect? There you have to mark the dot and circle it so that it's visible. Because you people are doing it with pencil. In exams, it may not be easily visible, the dots. So we circle them so that they are easily visible. Raise your hand who is not clear with 14 and 32 intersection. So I'll not explain the rest, I'll directly plot the rest of the points. Everyone is clear with 14 and 32? See, next is 16 and 50. 16 directly available, 50 also directly available. So wherever 16 and 50 intersect, straight away you mark the dot and circle it. Okay? Then 12 and 20. 12 is directly available, 20 also directly available. So wherever they intersect, dot and circle. Raise your hand who is not able to follow. Then 11 and 12. 11 directly available, but 12 after 10. 11, 12, 13, 14, 15. So 12 would be approximately here. Okay? 11 and 12 is intersection. Anyone who did not understand this? In exams, if they ask you this question and provide the graph paper, then perfectly you get the points. On the graph paper, you get the points perfectly. Okay? For 15 and 45. 15 we have, 45 also we have. So directly their intersection can be obtained. Then 13 and 50. 13 and 50 both are exactly available. And last is 17 and 53. 53 means after 50, 51, 52, 53, 54 and 55. So 53 is here. 17 and 53. Do you all get this kind of a diagram? 13 and 30. Sorry, I marked it 50. 13 and 30 would be here. Okay? 13 and 30. Is everyone able to get this kind of a diagram? Now, we studied yesterday 5 scattered diagrams. Perfect positive, perfect negative, partial positive, partial negative, no linear correlation. Which one does this look like? Partial positive. That conclusion we have to write. So below that diagram, you mention thus. Below the diagram mentioned, we don't write inside the diagram. Thus there is partial positive correlation between price and supply. Below the diagram you must write this statement. So has everyone understood this? Any confusions? So question 2, we'll decide this scale and solve it. Okay? Anyone still solving with the first one? Or you did Rudra? Raise your hand who is still solving the first one. So look at question 2. A company manufactures RO plants for the factories. The information about the advertisement cost for its sale and its profit from the sale of RO plants is given below. Advertisement cost you'll mark it as X. Profit you'll mark it as Y. What is the minimum RO cost? Sorry, advertisement cost? 5. Maximum? So like, what will we take the scale? 11. What will we take the scale? 1 unit only. And we can directly start with 5. You'll break this line. 5, 6, 7, 8, 9, 10 and 11. In case of y-axis, what is the minimum? 7. Maximum? So there also we'll break the line. We'll start directly with 7 and keep the scale of 1. So 7, 8, 9, 10, 11, 12 and is everyone clear with this? Draw a scatter diagram from this information and state the nature of relationship between the advertisement cost and profit earned from the sale of RO plants. So here that is question 2. Scatter diagram showing correlation between advertisement and profit. On x-axis we will show advertisement cost in bracket. What are the units? 10,000 rupees and profit lakh rupees. So what we'll do on x-axis, we'll directly start with 5. You'll break the line and then 5, 6, 7, 8, 9, 10 and up till 11. Any confusions? Same way, on y-axis the minimum is 7, so we'll directly start with 7 and right up till 13. Here also you break the line 7, 8, 9, 10, 11, 12, and here you mention scale. On x-axis, what will we write? 1 centimeter equals to 10,000. We have taken 1 centimeter 1 unit, but what is the unit? 10,000. So 1 here means rupees 10,000. And on y-axis, 1 centimeter is equal to 1 lakh rupees. Here the unit is in lakhs. So rupees 1 lakh. 1 more minute for plotting the points. Do it fast. 1. All of you have completed? Now see here, what is the first point? We have to mark the intersection 5 and 8. So on x-axis we directly have 5 available and 8 is also directly available. So 5 and 8's intersection. Getting it, everyone? Next one is 6 and 7's intersection. Next is 7 and 9's intersection. Next is 8 and 10's intersection. 9 and 13's intersection. 10 and 12's intersection, and 11 and 13's intersection. Do you all get this kind of a diagram? Complete it fast. Kajal, what will we interpret? Partial positive. Is everyone able to understand this? Again, looking at the diagram, you can say it is partial positive. So that statement conclusion you get at the bottom. Thus, there is partial positive correlation between advertisement and profit. So, anyone having any confusions in this? Who are still solving it? Raise your hand. No one is solving. Everyone has completed. So, shall I take up with question 3? Look at question number 3. Generally, practical numerical based questions would be asked. If this comes in exams, you'll be fortunate enough because it will be 5 marks. You'll be lucky to get directly. So, very less chances, but if it is asked, then you'll be very lucky enough. The following information is collected to study the relationship between the minimum day temperature. Question number 3, okay? And sale of woolen clothes during a particular day of winter for 6 different cities. Minimum day temperature market as X in degrees Celsius and sale of woolen clothes 1000 units market as Y. Now, what is the minimum value in temperature? 5. Maximum 24. So, but how shall we take the scale? 2, 4, 6, 8 up till 24. That can also be done. Alternatively, raise your hand. What else can be done? With less labor and time. Tanushri, 5, 10, 15, 20, 25. Sorry. And by June. In case of sale of woolen clothes, minimum is?
Minimum is 8.
8 and maximum is?
70.
70. How can you take the scale? 5, 10, 15, 20 up till 70, or alternatively you can also take 10, 20 because maximum are in 10 and 5s. So you can take directly 10, 20, 30, 40 up till 70. Is everyone clear with it? No need to break the line in any of the cases because we'll be taking the scale of 5 and starting with 5. We'll be taking the scale of 10 and starting with 10. Understood that? So, right now, question 3. Scatter diagram showing correlation between temperature and sale of woolen clothes. On x-axis, minimum day temperature in bracket Celsius. On y-axis, sale of woolen clothes in bracket 1000 units. Now, we'll be taking from 5 to 25 and 10 to 70. So, no need to break the line. Straight away, you can start with 5, 10, 15, 20 and 25. Here, 10, 20, 30, 40, 50, 60 and 70. You can mention the scale here. On x-axis, 1 centimeter equals to 5 degrees Celsius, and on y-axis, 1 centimeter is equal to 10,000 units. It is 10, but then it's expressed in 1000 units, so 10,000 units. Is everyone clear with this? 1 minute's time completed, everyone. But we have taken scale of 10, so 10,000 units. Okay, if you take scale of 1, 10, 11, 12, 13, then 1,000 units. You are taking a gap of. Anyone else having any confusions? Raise your hand who is still plotting the points. All have plotted the points. Yes, we ended. 12 and 35. Now 12 means we'll have to get it approximately, like here you can see 10, 11, 12, 13, 14, 15. So this would be 12, and 35 means exactly between 30 and 40. Is everyone able to understand this? So 12 and 35 would be this one, the point of intersection. 20 and 10. 20 is exactly available, 10 is also exactly available. This is the point of intersection. All able to get it? 8 and 45. Now 8. So 5, 6, 7, 8, 9, 10. This one is 8. And 45 means exactly between 40 and 50. So 8 and 45 will intersect here. Able to understand this, everyone? 5 and 70. This one is 5 and 70 is exactly available. So 5 and 70. 15 and 20. This one is 15 and this one is 20. So 15 and 20. 24 and 8. So after 20, 21, 22, 23, 24, 25. This one is 24. And 8 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one is 8. 24 and 8 somewhere here. So does everyone get this kind of a diagram? Number what will we interpret? Anuj, what will we interpret? Perfect negative. It's a straight line. Partial negative. Okay, if it's a perfect straight line, then only perfect negative. This is partial negative. Did everyone understand this? So write down this. Below the diagram you write this. There is partial negative correlation between temperature and sale of woolen clothes. Understood this, everyone? So all of you are clear with the first method of correlation, scatter diagram method. Illustration 1 to 4 is your homework. TO2. Okay, 1, 2, 3 and 4 is your homework. They are based on scatter diagram. Homework notebook to be maintained separate from classwork notebook, and scales etc. I leave it on your own to decide. You must be able to decide on your own. Okay. Now what is the limitation of this scatter diagram method? Understand it? We can judge whether it is partial positive or partial negative. But exact value of R, which we will be able to find in Karl Pearsons and Spearman's rank correlation, is not obtainable here. Like partial positive, R is always between -1 and +1. But in partial positive, is it 0.8? Is it 0.9? Is it 0.76? Exact value in scatter diagram cannot be. This is the only limitation. You can be asked for 1 mark in exam in section B. What is the limitation of scatter diagram method? Exact value, exact strength, exact degree of correlation cannot be. Okay. Look at page 66. At the top you'll find merits and limitations. I'm discussing them, we'll learn it and come tomorrow. In between 7:15 to 7:30, between the lecture, you'll be writing it. So look at it. Merits. First one. This is a simple method to know the nature of correlation between two variables. It's simple, we have seen it already. And less mathematical knowledge is required, as the knowledge of plotting the points is the only requirement in this method. Calculations are not involved. It also gives some idea about the strength of correlation. For example, like this one, can I say it is high degree of positive correlation because the points are close to the straight line? If they are close to the line, high degree. Away from the line, so some idea about the degree or strength can be. The scatteredness of the points suggests whether correlation is linear or not, we can find out. And fifth, there is no difficulty in judging the nature. Very easily you can find, is it positive or is it negative. Even if some pairs of extreme observations are present in the limitation, as I discussed, what is the only limitation? Exact degree, strength cannot be obtained. This method gives the nature of correlation and some idea about the strength of correlation, but underline, it does not give exact degree of relationship between two variables. Alright everyone, so this you will learn and come tomorrow again. Now in the summary where you have left 2 pages, you get the heading Karl Pearsons product moment method. We take up the formulas of Karl Pearsons product moment. Yes, dear, you write the formulas along with me so that you don't make any mistake in that and later on don't land up getting a position. First formula, there are 6 formulas of it. So note it down carefully. First one, write down R is equal to. Okay, we discussed yesterday coefficient of correlation is denoted as R. COV. Covariance between x and y. COV bracket x comma y. And how do you read this as? Covariance between x and y. upon Sx, standard deviation of x, into Sy, standard deviation of, okay. We studied standard deviation and variance in the last year. Covariance between x and y means joint variance between x and y. So how is this covariance obtained? Covariance between x and y is equal to sigma x minus x bar, again in bracket y minus y bar upon n. But will not be required to find it. We'll be using this formula in short questions where all the three informations are directly given. We just need to apply the formula and put the values. That's it. Okay? We'll not be using it in long questions, we'll be using it only in short questions. Okay? Covariance can be obtained in one more manner. Sigma xy minus n x bar y bar upon n. Both will always give you the same answer. And second and third formula we derive from this substitution. When in covariance x and y, you substitute the first formula of covariance, you get the second formula. And when in covariance you substitute the second formula, you get third formula of R. Means, in place of covariance now, I substitute the first formula of covariance. That is, sigma x minus x bar, again bracket, y minus y bar upon n. What does this stand for? Covariance between x and y. Other than that, what remains in the denominator? Sx into Sy. This is the second formula. Did you understand this? In covariance between x and y, I have substituted sigma x minus x bar, y minus y bar upon n, and Sx and Sy remains. Same way, if you substitute the next formula, you get the third one. Raise your hand. What would be the third formula of R? Exactly same way. If you substitute this second formula in covariance, you'll get the third formula of R. Darshan? Correct. Okay, first in covariance, we'll write that. What is the second formula? Sigma xy minus n x bar y bar upon n. What does this indicate? Covariance between x and y. What remains? Sx into S. Did you understand this? Has everyone written the first three formulas? Okay. First three formulas will be used only in short questions where directly the information is, means respective formulas we can identify based on the information given and apply the formula. Okay. Next three formulas we'll be using in long questions as well as short questions. So fourth one, write it along with me and listen carefully, see carefully and write it. N sigma xy, n sigma xy minus sigma x into sigma y, n sigma xy minus sigma x into sigma y. Did you already tell you? Upon square root of n sigma x square, n sigma x square minus bracket sigma x bracket close whole square. Okay, n sigma x square minus sigma x whole square. Sigma x square is different and sigma x whole square is different. Again into square root of, same way with y, n sigma y square minus bracket sigma y bracket close whole square. Okay, n sigma xy, check it carefully, minus sigma x into sigma y upon square root of n sigma x square minus sigma x whole square into square root of n sigma y square minus sigma y. Fifth formula, exactly same as fourth. X will be replaced with u and y will be replaced with v. So n sigma uv, x replaced with u, y replaced with v. Minus, what will we get? Sigma x will become
U.
sigma u. Sigma y will become sigma v upon square root of, yes, what will we write n sigma x square now? N sigma u square minus sigma u whole square into square root of n sigma v square minus bracket sigma v whole square. Did you understand this? What is this u and v? Last year we studied in mean direct method and short method. What do we use to obtain in short method? D. How do we use to obtain di? Xi minus v. That is u and v. Last year we had only one variable x, but now we have two variables x and y. So we cannot denote it as d for both of them, otherwise it will become dd. and which D stands for which deviation of x and y cannot be asserted. So because there are two variables, instead of denoting it as D, we denote it as U and. So this is like x minus assumed mean, and this is like y minus assumed mean. Is everyone familiar with this? So there is a direct method and this is the short method. But because there are two variables, instead of D we write U and. Any confusions? And the last one, R equals to sigma x minus x bar y minus y bar. R equals to sigma x minus x bar in one bracket again multiplied by y minus y bar in another bracket. Divide by square root of sigma x minus x bar whole square into square root of sigma y minus y bar whole square. Okay, square root of sigma x minus x bar whole square into square root of sigma y minus y bar whole square. Right, everyone? These three will be used in long questions as well as short questions. How to use it, I'll discuss it from tomorrow once we start with the questions. Which long question we shall use fourth formula. Means tomorrow we'll practice fourth formula based questions. Day after tomorrow, sixth formula based questions. And 2 lectures will have to devote for fifth formula. This is the most important. So that we'll see in the coming lectures. Okay. Now as I remember all the 6 formulas perfectly well, you can also do this directly. So what you're supposed to do for that is write this 6 formulas. So you also remember it perfectly well. And again, how to write it 20 times, be careful and listen carefully. First you write first formula 10 times. R equals to covariance x y minus s x y, covariance x y minus s x y 10 times. Then you write second formula 10 times, third formula 10 times, fourth 10 times, fifth 10 times, sixth 10 times. Then 11th time write all the 6, 12th time write all the 6, 13th time write all the 6. So do it in 2 parts. First you write individually 10 times, so you remember each formula. Then you write all the 6 10 times so that you perfectly remember and don't get mixed up with the formulas. Did you understand the pattern of doing it? Any confusions? We can take up with one small question of interpretation. Look at page number 111. Page number 111. Exercise 2, section D, question number 5. Yes, see that. Interpret. Raise your hand. R equals to 1. What will you interpret? R equals to 1. Rushdi? Yes, perfect. Positive correlation. What will you interpret for R equals to minus 1? Kushi? Perfect negative correlation. What will you interpret for R equals to 0? Raise your hand. R equals to 0. Rudra? No marks. Raju? No linear correlation. Yesterday I discussed with you if R is 0, don't make a mistake of writing no correlation. What will you write? No. In this chapter, what are we studying? Linear correlation. What does R stand for? Linear correlation coefficient. Is everyone clear with it? So let us R equals to 1. Perfect positive correlation. R equals to minus 1. Perfect negative correlation. And R equals to 0. No linear correlation. Understood this, everyone?